Guys, hello and welcome to today's session on Introduction to Docker. We're going to be talking about what Docker is, why do we use Docker, and all that other jazz. So we'll just begin in a few minutes. Now, you might have heard of Docker on, let's say, Medium articles or blog posts, stuff like that. You might even have heard your friends talking about how they use Docker in some sort of project or something like that. So you might be wondering what exactly is Docker and why do we use it and what's its purpose, and that's what we're going to try and answer today. Um, so let's get on with it. So to begin with, we'll be answering these two basic questions: what is Docker and why do we use Docker? The first question we are going to answer is why we use Docker, mostly because it's easier to answer. So let's begin. Yeah, why use Docker? There's so many reasons why we should use Docker, but I'm going to answer one of the most basic requirements and like one of the most basic reasons why Docker was created in the first place. Now here is a flow diagram that you've probably gone through at least once in your lifetime, which is that of installing software on your local machine. Now you'll go through some of the steps, like you'll download an installer, you'll run the installer, you might get an error message during installation, and if you do, you'll need to troubleshoot that issue, which you'll probably do by going on Google, Stack Overflow, stuff like that. And after you solved it, you'll rerun the installer, and chances are you'll run into another issue, which leads to this whole super annoying cycle of fixing issues, restarting installers, stuff like that. Now, this is exactly what Docker is trying to fix. So, the answer to why we use Docker is that Docker makes it really easy to install and run software without worrying about software setup or its dependencies. With that out of the way, let's go back to our first question, which is what is Docker? Now, this is slightly more difficult to answer because we'll be running into stuff like operating system fundamentals, but we shouldn't be afraid of that, so let's just dive straight into it. So, what is Docker? When someone tells you that they use Docker for their project, they're referring to something called a Docker ecosystem. It's not just one thing. A Docker ecosystem is a collection of software, tools, documents, stuff like that, um, which is a platform for creating and running containers. Well, you might say that's all fine and good, but this begs another question: what is a container? And to get to that, um, a container is like an instance of an image. If you have uh, experience with object-oriented programming software, you might have heard of the words class and object. So basically, an object is an instance of a class. In the same way, containers are instances of images. Now again, that doesn't really explain what a container is, and it also brings up this new terminology of what an image is. So let's just clarify these two concepts before we proceed further. And I find the easiest way to do that is by running a few commands in the terminal. So right now we'll just take a 2-minute break, and when we come back, we'll be running some commands in the terminal. Alright guys, welcome back. Now we are going to talk about um, basically um, how we run containers and stuff like that. So let's just jump into the terminal, and here we are in our terminal. I hope you can read that. Just leave a comment in the chat if you're not able to. But let's begin. First, I'll just demonstrate how easy it is to run software. For example, Redis. Now, Redis is like a stateless database cache, and here we see on its home website a bunch of commands for um, running or installing Redis on your local machine. Now sure, these look easy, but this make command is for compiling software on your local machine, and chances are you'll run into an error when you're doing that because you might run into missing dependencies or an environment may not have been configured properly, stuff like that. So I'll demonstrate how with just one command we're able to get Redis up and running on our local machine. Now the command we are going to use is docker run -it Redis, and after just a few seconds we are able to see Redis running on our machine. Now isn't that cool? I mean, we didn't have to run any of that complicated stuff. We didn't have to download any archives, stuff like that, and with just one command we are able to get Redis up and running on a machine. How cool is that? Now that's just a small demonstration of how powerful Docker containers, images, stuff can be. And now we'll just to coming back to our diagram, we'll explain what containers and images are. And for this, we can run another command on our terminal. Now the command we are going to run now is docker run hello world. Now this might seem boring, like just a hello world program, but trust me, it's going to be interesting. There's a lot of interesting stuff that happens here behind the scenes, and we're going to walk each of us right through it. So let's get it. Now very first off, we see this message, unable to find image locally, and it says it downloaded the image, and it says hello from Docker, and that's exactly what it's supposed to do. It's just supposed to show hello world. But here we see that it says Docker took 4 steps to generate this message. And now let's break down each of the steps using our diagram. So here we come to our first run, and in the previous you might have noticed that when we ran the Redis command, we didn't have this unable to find image locally message pop up on our machine, and the reason for that is that I had Redis image in our local cache. So exactly what happened when we run this command, docker run hello world, is we invoke the Docker client, which in turn contacted the Docker server. Now you might ask what these are. If you are familiar with web technology, you must have heard of the terms a client and a server. Well, that's exactly what these two are, except they both are running on the same machine. Now what happens is the Docker client acts like a front end. It contacts the server and asks it to do all of the heavy lifting, behind the scenes stuff, configuration, and makes it really easy for us to interact with Docker. So the Docker client exposes an easy to use interface for users to use, and the Docker server takes care of all the heavy lifting behind the scenes. So what exactly happened when we ran docker run hello world was the Docker server first checked our image cache to see if there was an available image for hello world, which clearly there wasn't because we saw this message, unable to find image locally. And yeah, so after that what it did was it contacted something called the Docker hub. Now you must have heard of GitHub. Now GitHub provides repositories for storing code freely, and it's free and open source. So Docker Hub is basically just like that, except it offers repositories for storing Docker images. So what Docker server did was it pulled the hello world image from Docker Hub and downloaded it to our image cache. Now our image cache has this. So I mean, you see here, downloaded newer image for hello world, and it saved it to our image cache and then ran it. Now again, this might seem a little bit confusing about what an image is. So for that, we'll need to take a step back and go into detail about how an operating system works. So now, most modern operating systems have something called a kernel, and a kernel is basically like middleware or a middleman which acts like an abstraction layer between the processes running on your computer and the hardware resources which are available to the processor. So suppose you saved some file to your computer using Node.js or using Chrome. Uh, it's not exactly Node.js which is saving your file to the hard disk. What it does is it sends a request to the kernel. The program issues a request to the kernel to interact with your hardware, and it does that through something called a system call. Now the kernel will listen to the system call and do what it's supposed to do. It will write the file to your hard disk, and that's how most modern programs, like all programs, interact with your hardware resources. But you might ask, what does this have to do with containers or images? And we are getting there. Now, as you might have noticed, the container is like, um, I mean, it the container, the name itself, it evokes images of something being isolated, running inside isolated space. Now, that's exactly what a container is. It's isolated from the host operating system, and that's where the kernel comes in. Now, the kernel has these two specific features which are used by Docker to provide isolation to a container. Now, what those features are is namespacing. Now, namespacing is a feature which isolates your hardware and software resources for a single process or a group of processes. Now, your resources don't need to be just stuff like your hard disk, RAM, CPU. They can be stuff like other processors, inter-process communication, your network stack, your host name, stuff like that. And what it does is it will basically isolate these for only certain processes. For example, you might have like this certain area of memory is reserved for process A or process B, stuff like that. Now we come to the next feature, which is control groups. Now control groups are used to limit the amount of resources which are used per process. Now, now this is because we don't want a single container to use up all the space on a hard disk, do we? No. So what control groups do is they'll isolate stuff like memory, CPU usage, or your I/O network bandwidth per process. Now these two features together are what help Docker isolate your container. And so let's just get over to a container overview. Now this is a representation of a container. A process interacts with the kernel, and the kernel allocates a portion of your hard drive or network, RAM, and CPU for each process or processes inside the container. And that's all it is. It's just a process which is running in an isolated environment thanks to these two features called namespacing and control groups. So well, that's one term out of the way. Now what we have left is what an image is. Now I might have just said that an image is a blueprint for a container, but what exactly does that mean? And what's the relation between an image and a container? So we'll get to that in this next diagram. And here we see a representation of a container and of an image. And as you can see here, an image is a blueprint. It's basically just a file system snapshot. Now what that means is it's just a set of directories and files and folders and stuff like that saved, basically just your application and its dependencies. And the second thing it contains is a startup command. The startup command is something we'll come to in just a second, but now I'll explain what the relation between an image and a container is. So when you ran that command, this command, docker run hello world. Now what happened is the Docker daemon created a new container from that image. Now again, this creating a new container from an image, how exactly does it work? Well, how it works is the Docker server will take this file system snapshot and it will put it in the hard disk space allocated to this container, and after that it'll take this startup command and it will run it inside the container. And that's basically all a container is. It's just an isolated process created from a file system snapshot, which is an image. And that clears up both of our terminologies and of what is Docker and why do we use Docker. Now there's just one last thing I want to tell you before we take another break, and that is how Docker works on non-Linux machines. Now, you might be confused as to why this is. It's because these two features, namespacing and control groups, are available only on the Linux kernel. They're exclusive to the Linux kernel. And again, that brings us back to our question. How does Docker work on non-Linux machines? Now, all that it does is it runs a Linux virtual machine on top of your host operating system, which provides these two features to your running container processes through a Linux kernel. And that's all it is. Now, that concludes our introduction to what is Docker and why we use Docker. We'll be taking a small break now, and when we come back, we'll be creating a small web app and deploying it in production to um, show how Docker can be used for real life applications. Hello and welcome back to today's webinar on Introduction to Docker. Now we're going to create a small Node.js web app to demonstrate how Docker can run in real life and for real life applications. So if you aren't familiar with Node.js, there's no problem. I'll be writing the code right here and you'll see how it works. So let's just get to it. First we'll open up our terminal and we'll create a directory for the sample application. So let's just call it sample app. Then we'll go into the sample app directory. Excuse me. Yeah, and it's empty. So we'll just create an empty Node.js project here by using npm init. And npm will just ask us a bunch of questions which we can just fast forward through, and it's okay. Yes, it created our package.json. So now what we are going to do here is we're just going to open our code editor, which in this case happens to be Visual Studio Code, and open up that directory. Yeah, now we'll just open up the directory. Open folder. It's right here, sample app. Alright, now we have a package.json here which just basically specifies what name, version, description, stuff like that. And we're going to just replace this script with a start script, and they're just going to run node index.js. Now we'll save that and we'll create a new file. We'll just call it index.js because that's all we're going to do, right? Then we'll just include in express, and then we'll create an app using express. And we'll add just a get route to it, which will be on our root route, and we'll just pass in an arrow function of request and response, arrow function, and all we'll do is send a response of hi there. Yeah, that sounds simple enough. And then we'll just listen on a particular port, let's say 8080, and arrow function as a callback, and we'll just console log out listening on port 8080. Now this sounds good to me, but you might have noticed a slight problem here. Express, we have not included express, so we'll just get to that by running a simple command in our terminal, which is npm install -- save express. And that'll just download our dependencies and save it to our local file. Now this is all well and good, so we can just we'll just run our app by running npm start, and it will listen on port 8080, and we'll just open up that local host 8080, and we get a response, hi there. So our Node.js app seems to be working. So now let's get to the process of Dockerizing it. Now by Dockerizing I mean we'll create an image for this, and using Docker and that image will be created using something called a Docker file. So let's get to that. um, we'll create something called a Docker file, and its syntax is pretty simple. And yeah, um, remember, the Docker file is called just Docker file. There's no extensions, nothing. And you can see that Visual Studio Code is picking up a little Docker icon here. It also needs to start with a capital D. So yeah, and that's our Docker file. So we'll just install the extension as VS Code recommends, and after it's installed, we'll start writing out the syntax for the Docker file. Now the Dockerfile syntax is really simple. Now I'll just type out the syntax, and then uh, I'll explain what those mean after we are done. And that is our Docker file. So now we'll go back to our terminal, and we'll close this sample app, and I'll clear the screen. And now we'll create an image from this Docker file. Now the syntax for building an image is docker build and the app context, or basically where your Docker file exists. Now it exists in the current directory, so I'm going to press dot. And you might see a bunch of steps. Sending build context, it's pulling something from library, and I'll explain all the steps after we are done. And now we get something called successfully built some string of numbers, which is basically a hash. Now that's not really convenient for running an image now, is it? So what we're going to do is I'm going to tag the image. Now tagging is basically just giving it a name, and all it requires us is to change the syntax of the docker build command a little. So what we're going to type is docker build dash t your docker hub username slash the app name. Now keep in mind, this is just convention. It is not necessary to do this, but if you follow the convention, it makes pulling images from the hub a lot easier. Yeah, and then the dot. Do not forget the dot. It's required. We need to pass in a build context. So we'll just run this command. Oh, excuse me. This needs to be lowercase. Yeah. And you might have noticed that this ran really quickly because it said it's using the cache, and it tagged the image. Now I'll explain the cache later, but for now let's just run this app. um, Docker run, and the syntax for running an image is that. And now we are running the app, and you might notice it says listening on port 880. Hey, our app seems to be working, so let's just head over to our browser and we'll reload. But whoa, we see this unable to connect message. What could this be? Now, as you might have imagined, our Docker container is completely isolated from the outside space, and it won't be given extra resources unless we explicitly allow it to. And that's exactly what's happening here. Our Docker container is isolated, and it's not able to access this port. So what we are going to do is we are going to bind our local machine's port 8080 with the port 8080 inside the container. And how we're going to do that is just by using the docker run command with a slight modification. And the modification is going to be we're going to type docker run dash p 8080 8080 and the image name, which is this. Now you might be wondering what this minus p 8080 8080 means. So this slight flag just tells Docker to bind port 8080 inside the container with the port 8080 of our local machine. And let's just run this and we'll see what happens. And it says listening on port 8080, so let's just refresh our localhost 8080 and we get our response. Hi there. Wow. So our app is successfully running as a Docker container. Wow, that's so awesome, isn't it? Like our first container. But for now, let's just shut it down and then I'll explain what this Docker file did. So now, first we come to this from node Alpine. So what we are actually doing here is just like in object-oriented programming, we extend classes and add our own implementation on top of them. We are pulling an image to use as the base for the new image we are creating. So I'm just going to put a comment here to explain what we did. Pull base image from Docker Hub, and that's exactly what we did. And so if you are confused about what this node image is, our VS Code offers this helpful little follow link. So, oh damn it. So I'll just go to the web browser and we'll just look at Docker Hub node. And yeah, so we see here is this image is available freely for everyone, and the tag we are using is Alpine. Now you might be wondering what Alpine is. Alpine is basically just specifies that we want the smallest, lightest Node.js image available. That's derived from Alpine Linux, which is a really light version of Linux. Like it's really light, like no bloat installed, etc. Now coming to the next step, copy dot slash dot slash. What does this mean? Now what copy does is it will copy the files inside our working directory here, like all these Docker file, index.js, node modules, package.json, package log.json, into the container, and this dot is taken from the build context, which we specified when we use the docker build command, if you recall. So I'll just add another comment here to explain what we did, which is copy application specific files into container. That takes care of our second step. Now we come to our third step, run npm install. Now for those of you familiar with Node.js, npm install basically just installs the dependencies specified in your package.json. Now here we have the dependencies of Express, and now what this run command here does is inside the container it will run this command to install all our dependencies. And so let me just add another comment which explains what this command does. Install application dependencies inside the container. Yeah, and that brings us to our final line, which is cmd npm start. And as you can guess, this is the start command. When I explained in this diagram here of what an image is, it's basically this. It's the startup command. When we specify this is the startup command that the image is going to have. specify startup command, and that's it for our Docker file. But now let's get on to something slightly more interesting. Let's say we rebuild, let's say we make few changes to our index.js. How about just making it hello there? Yeah. Now, and we'll rebuild our build process. Now, as you can see, this time it did not say anything like building from cache as it did previously. Now you might be wondering why that is. It's because at each step Docker checks if the previous container has changed. For example, like the step 1 pulls a container from node Alpine. It will create, and its container hash is this. Now it uses this container to copy this file into this, which generates another container with a new hash, and it will use this container for running this npm install command, which generates yet another container called this. Now if the container in the previous step has changed from when we last ran the build, Docker will not use the cache. Now this might run into like some slight problems, you might imagine. For example, like suppose we have a really big app, and for even a small change we like just copying this stuff, but we haven't changed any dependencies. This sort of stuff will make it not use the cache every time we change the whole app. We change even a small thing inside the app, and this is called cache busting. So how can we remove this? We can be slightly smart, and we'll just make a few modifications in the Docker file. So at our Docker file, instead of copying // straight, what we'll do is we'll copy package.json into /, then we'll run npm install, and then we'll copy the rest of the files. Now how this works out better for us is because let's just run the command once again and we'll see. It'll copy package.json first, which is the only thing required for installing dependencies. So if something previously has not changed inside package.json, it will use the cached image, and so these three steps will be using a cached image, and this is the only step which won't. So this is a good way to avoid cache busting. And it built the new image, and we'll just run it again. Docker run -p 8080 8080 the tag, and to just run it again, localhost 8080, and again we get hello there. So we can see this did not introduce any differences, but it also made cache busting a lot less. So for now we'll take another 2-minute break, and we'll come back and we'll work on Docker Compose and a few other Docker related commands. So hello and welcome back. Now we're going to be talking about a bunch of general Docker commands which we can use for interacting with the Docker client and use to manipulate containers. Um, so let's just get to our terminal and we'll begin. Um, yeah, so here we are at our terminal and uh, the basic commands for interacting with Docker we just saw, which are docker build and docker run. But what about some other commands? What if we wanted to, let's say, see what Docker containers are running? We'll use the command called docker ps. It'll show you what sort of commands are running. Currently we have no running containers, but say we ran our container which we ran previously and open another tab for viewing, we can run docker ps and we'll see um, a container is running. So that's cool because our container is running here and we're able to see it here. Now there's a variation of this docker ps command which is docker ps minus minus all. Now this will show all the containers which have ever existed on our machine, and we can see here we had redis, hello world, and a bunch of, that's the container before we tagged it, and this is after we tagged it. um, yeah, that explains how to see all the running containers and containers that have run in the past. Uh, Now let's get to how about going inside a container and seeing what happens. So we have this container which is running here, and suppose we wanted to explore what is inside the container, like see what its file system is, what other files are, run commands in there. What we can do is docker exec minus it, excuse me, I need to have its hash first, so we'll run docker ps, and this is our container id which I'm going to copy, and we'll run docker exec minus it. Now what minus it flags are, it just makes the output when we connect to the container a bit easier to read and interactive. So that's all those flags are. So docker exec minus it and the program which we want to run inside the container and the container id which we want. So excuse me, I think I mixed those. Yeah, sh. Now sh is basically just the basic shell, and here we are inside the running container. We can see what all stuff this is. We can see our index.js file. Yeah, but there's no nano program, so yeah, here we can see all of the contents of our file, and this is how we get inside a container, and we can just use exit to exit from the container. But now suppose, what if we wanted to run a container um, from an image with a different startup command than what was actually inside it? Docker offers us a way to do exactly that. So what, instead of using docker run minus p and blah 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 all of that, um, what we can do is at the end we can just append name of the program we want to run, and this will override the startup command uh, which was defined inside the image. And we get no prompt because we haven't attached to the process yet. So what we are going to do here is docker run minus it minus p and then the shell, and this will run our shell as the very first command or the startup command inside the shell. So we did not start up the sample app. To prove that, we'll just go to localhost 8080, and as you can see, nothing is here. But suppose we do npm start instead of here, and I reload the page, and we get this hello there. So this proves that it replaced our default startup command, which was npm start as we defined in our image, and we replaced it with sh, which is just a basic shell. Now we can exit from this. Yeah, and that's basically some of the basic commands which we use for manipulating containers, and a bunch of other commands which you should know are stuff like docker um, container ls, which just shows all containers which have been created. Currently I have none because I ran a command for removing all dangling containers, stuff like that. So what we can use for clearing all containers is a command called docker system prune. Now as you can see, this will remove all stopped containers, all networks not used by at least one container, all dangling images, and all build cache. Now I'm just going to go ahead and clear this, and this will clear all the stuff that we created, including that Alpine Node Alpine image which we downloaded. So that's it for some basic commands, including docker ps, docker run, docker exec for manipulating containers after they have been created. Now we'll take another short 2-minute break and we'll come back and run a multi-container program using Docker Compose. So guys, welcome back to Introduction to Docker webinar. Now this is the final topic that I'm going to be covering, that is running uh, multi-container projects using Docker Compose. Now for that we are going to create a new sample app. So let's just get to our terminal and begin. So we'll exit our sample app directory and I'll create a new directory called, let's say, Redis app, because we are going to be using Redis in this application. So we'll just go to the directory and we'll use npm init and just to run through all the blah blah blah. Yes, install all dependencies, npm install -- save express and npm install -- save redis. So now we have our dependencies set up, and we have our package JSON, our package log JSON, stuff like that. So let's open up our code editor and open this directory. Now, as we can see here in our package.json, we have our dependencies, which is Express and Redis, and let's just create our application, which is again going to be just one single JavaScript file, index.js. Now we'll just require in Express and Redis, and then we'll create our Express client, and Redis client. Redis.create client, and I'll just leave this blank for now because this is some configuration options on connecting to your Redis instance, and then we'll just move on, and we'll add a single route like in our last app.get, which on our root, and we'll add in an arrow function, request, response, arrow function, and we'll just get the number of so what we are going to be making is like an application for showing how many visitors have been there to your web page. So we'll just do client Redis client dot get visits, and another arrow function which acts as a callback with an error, and the value of the visits, arrow function, semicolon, and we'll just do rest dot send number of visits, and we'll just use plain old string concatenation for visits. But and we'll just increment the number of visits because some one person has visited your web page. So we'll just do Redis, excuse me, it should be inside the callback, Redis client dot set, damn autocomplete, visits, and visits plus 1. Now there's a slight problem here because the visits we get from the Redis client is going to be a string, so I'll just wrap it in parse int, and we will set that. Now, but this also runs into a slight problem, which could be like before anyone visits the page, like there's no previous number of visits. So what we'll just do is we'll do Redis client dot set visits, 0. I think that takes care of our index.js web app, and then let's get to creating our Docker file for this web app. Excuse me. And we'll just create a new file called Docker file, and we'll edit it. It's going to be again from node Alpine, and this time I'll be making use of another functionality called workdir. Basically what this does is it'll um, use that as the work directory inside the container. So I'm just going to be making it /app, and we'll just copy our package.json dot and run npm install, install, and then we'll copy the rest of the files. Then we'll just use our command, which is npm start. Before this, we'll just have to edit our package.json a bit to add the start script, which is just going to be node index.js. And now we'll save this. But you might remember now, when we usually create a Redis client, we'll need to pass in something like a host. A host. Now, a host is usually something like a URL, or like something like https:// my Redis server, something like that. But this could run into problems because like we don't have one right here, and we are going to be using Docker Compose to create a host. So let's just get into it. Now, what is Docker Compose? Docker Compose is a command line utility that's installed along with Docker for help in orchestrating multiple containers together at once and removing all of the boilerplate stuff that we were typing, like docker run -plea blah 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 blah. All that boilerplate is eliminated by a Docker Compose file. So how do we do it? Simple. We'll just create a new file called docker compose.yaml. .yaml. And as you can see, again it's being tagged with a Docker symbol. And how we begin this, it might seem a little strange at first, but just bear with me. And how we'll start off with it is, we'll first specify a version 3. Now what this is basically just syntax, the Docker file syntax, Docker Compose file syntax. There are earlier versions like Docker version 2 or version 3, but we are going to be using version 3 because that's the latest and greatest, and that's what we all like to do, isn't it? Now, we're going to be adding another tag called services. Now, services basically just specifies which containers we are going to be running together at once. So I should think the first one which we are going to run is a Redis server. And that's going to be running an image called Redis. Excuse me, it should be a string. Yeah, Redis. And that's all for our Redis server app. But for our second container, which is the current one, like the app we just wrote, I'm going to call it, let's say, node app. And since that doesn't have an image as of yet, what we'll do is we'll just specify a build and its build context. So what Docker Compose will do is when running, it will build it while running itself. And for the port, remember I told you the Docker Compose file will take care of all of that boilerplate stuff which we ran every single time, and including that is ports, port binding. So what we're going to be doing is ports, and I'll be adding a dash. Now the dash is like, it specifies an array in syntax of YAML. So yeah. Now what this is saying is bind port 8080 on the local machine to port 8080 on the container. And I'll save this file, and we can get back to our index.js. Now again, how are we going to run our host? How are we going to connect to this? Now Docker Compose offers something really simple in such cases. Now when we created these two services, they are going to be linked together by a common network that Docker itself will set up. We don't have to do anything. So now all we have to do to connect um, to the host is specify the host name, and the host name in this case is just going to be this Redis server. So I'll just put it in host Redis server and a port which is going to be the default Redis port, which is 67379. Now this is our basic app, and what Redis doesn't know that this is not a link or a URL or something. What it'll do is it'll try to connect to this on good faith, like it'll just trust us and it'll try to do that all by itself. And then what Docker will do is Docker will intercept it and it will say, you're trying to connect to this service or this container, and it will forward the request to this image. And that's how easy it is to connect to a second container from inside one. And to get this up, what we're going to do is we'll go back to our terminal and we'll just run docker compose up. Now what this command does is it will start up both of these containers, and if one of these containers does not have an image, it will build an image from the build context we specified for it. We specified a build context, build dot, and that's what it's using. It's using that Docker file to create the node app routine. And it also created a network, as you might see, Redis app default with the default driver. Now this is exactly the network which is going to be used to connect to this Redis server from inside index.js. And we notice our app is nearly done, and once it's done, we'll open it up in our web browser. Yeah, and as we can see, oh, excuse me, there seems to have been an error with the index.js, so I'll just take care of that. Let's try running node index.js. Oh, that is strange. Excuse me while I debug this issue. I believe it is an issue with the Redis server. Let's just run Docker Compose up again. Yeah, and we just had a problem with Redis not being ready. We just reran node index.js and our server is running now. So what we'll do is we'll just go to localhost 8080 and we'll refresh. And we run into problems here as well, which is strange because I bound the ports. This is really strange, right? I don't see why it's not connecting. I mean, I did bind the ports. Maybe maybe I just have to save index.js. Let's rebuild our image and run it. Oh, excuse me. I'm so sorry. I forgot to start up the app client. I'm so sorry. It just slipped out of my mind. App.listen 8080, and we'll just console log out. What a stupid mistake. I'm so sorry, guys. Yeah, now we can cancel this and restart. Yeah. Docker compose up minus minus build. What we'll do is just rebuild the image, and as you can see, it used cache. What I explained from last time, it used the cache and it only copied these files because only those files had changed. The dependencies hadn't. Yeah, now we get our message listening on port 8080, and it should work now. We'll just run localhost 8080 and number of visits 0, but if we refresh we get 1 and 2 3 4 5 5 6, stuff like that. And if we close, since our container is already running, if we run it again, we'll get this thing persists. So as you can see, that is us running 2 containers at once using Docker Compose. That's the final topic I was going to be covering today. Thank you guys so much for coming here and watching, and I hope you learned something useful from this that you can take away and you can use it in your own projects for the future. Thank you.